Coulomb's law, ISC Physics Part 2. Coulomb's torsion balance. The torsion balance was invented by Charles Augustin de Coulomb to measure the magnitude of electric forces between charged objects. It works on the principle that like charges repel each other. Like here you see, positive repel and negative also repel. The charged brass sphere, when touched with the metal disc, shared its charge with the metal disc by conduction, and the same charge developed on the metal disc, so they repelled each other. Coulomb's torsion balance. It consists of a cylindrical glass case closed by a lid, a brass sphere initially neutral at the end of a glass rod is touching a metal disc. A scale circumscribed on the glass case is used to measure the torsion produced in the torsion fiber. The torsion fiber inside the glass tube is suspended by a torsion head. Initially, the brass sphere and the metal disc are uncharged. The brass sphere was removed from the case and charged. The charged brass sphere is placed back into the balance in contact with the metal disc. The brass sphere shares its charge with the metal disc by conduction. Now, since both the bodies have the same charge, they repel. Next, the charged brass sphere was removed and made to touch another neutral sphere of the same shape, size, and material. The charge on the brass sphere reduced to half. The brass sphere was placed back in the glass case. This time, repulsion was less. Also, in one set of measurements, he changed the distance between the charged bodies and found that the force between two charged bodies follow an inverse square law. The experimental results of Coulomb clearly shows that the force between two charged bodies depends directly on the product of the individual charges and inversely proportional to the square of the distance between them. Therefore, we have F is proportional to Q1 into Q2 by R square. The modern version of the law discovered by Coulomb is as follows. Coulomb's law states that two like charges attract and two unlike charges repel each other with a force which, for the point charges in vacuum, is directly proportional to the product of the magnitude of these charges and inversely proportional to the square of the distance between them. So F is directly proportional to Q1 into Q2 divided by R square. Here F is the force between the two point charges Q1 and Q2, and R is the distance between them. This force is directed along the straight line joining the point charges. We can write F is equal to K into Q1 into Q2 by R square. Here K is a constant. Now to find the value of the constant K. If 1 Coulomb charge is placed at a distance of 1 meter from another similar charge in vacuum, the force between them is found to be 9.0 into 10 to the power 9 Newton. Exactly 8.98742 into 10 to the power 9 Newton. Putting this value in F is equal to K into Q1 into Q2 by R square, we have 9.0 into 10 to the power 9 Newton is equal to K into 1 Coulomb into 1 Coulomb by 1 meter square. On solving this, K is equal to 9.0 into 10 to the power 9 Newton meter square per Coulomb square. The constant K can be expressed in terms of the quantity read as epsilon naught. Here epsilon naught is known as permittivity of vacuum and has a value of 8.854187817 into 10 to the power minus 12 farad per meter. This is the SI unit of epsilon naught. Or epsilon naught is equal to 8.854187817 into 10 to the power minus 12 Coulomb square per Newton per meter square. Now, K can be expressed as K is equal to 1 by 4 pi epsilon naught. The Coulomb's law in scalar form can therefore be written in the following form. F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square. Here, F can also be written as F vacuum, since we are using epsilon naught. While applying Coulomb's law, the following points should be noted. Number 1. Coulomb's law holds good only for point charges in free space. By point charges, we mean those charge bodies whose size are negligible compared with the distance between them. By free space, we mean vacuum. Number 2. The direction of the force F is always along the line joining the 2 point charges Q1 and Q2, and it is repulsive when Q1 and Q2 have the same sign, and attractive when they have opposite signs. Now let's come to relative permittivity or dielectric constant K. Here we'll see relation between permittivity of free space and absolute permittivity of medium. Note. But first let us see the meaning of permittivity. It is the property of a material medium which measures the opposition offered against the formation of an electric field. We can say permittivity is the property of a medium that affects the Coulomb's forces between 2 point charges which are placed in that medium. Coulomb's force is maximum in vacuum or air. The Coulomb force in other medium can be measured relative to this value. Now let's come to relative permittivity, that is also known as dielectric constant. We have seen Coulomb's law in vacuum. F vacuum is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square. Here epsilon naught is permittivity of free space. Now, if the charges are present in some medium other than vacuum, the value of the permittivity will change due to the effect of induced charges in the medium. Now, Coulomb's law can be stated as F is equal to 1 by 4 pi epsilon into Q1 into Q2 by R square. Here, epsilon is absolute permittivity of the medium. Now, on dividing 1 by 2, that is the first equation, divided by the second, we will have F vacuum divided by F is equal to epsilon by epsilon naught. The RHS of both sides will cancel out to give this value, and epsilon by epsilon naught is equal to epsilon R. This is relative permittivity. So we can say relative permittivity ER is equal to relative permittivity epsilon R is equal to epsilon by epsilon naught. Now, from equation 3, this equation, we have F is equal to F vacuum by epsilon R. Here you see F transferred to the other side and epsilon R transferred to the denominator, and we get this. And this can be written as F vacuum by K. Here K in capital is the dielectric constant, and it is the same as relative permittivity. Therefore, from equation 1 and 4, F is equal to 1 by K, inside bracket 1 by 4 pi epsilon naught into Q1 into Q2 by R square. This value is in a real medium. Now we come to vector form of Coulomb's law. Q1 and Q2 are the two similar charges under consideration. Now, in order to indicate the position of Q1 and Q2 from the origin O, we draw position vector R1 and R2 to Q1 and Q2. Now, the distance between Q1 and Q2 in vector form can be taken as R12. This is the displacement vector from Q1 to Q2, as you can see from the figure. R12 is the displacement vector from Q1 to Q2. Or the distance between Q1 and Q2 in vector form can be written as R21. This is the displacement vector from Q2 to Q1, as you can see from Q2 to Q1. This is R21. Now, since both Q1 and Q2 are similar charges, both are positive, the electrostatic force between them will be of repulsion. Therefore, the vector F12 is the force of repulsion on Q1 due to Q2. Here you see vector F12 is the force of repulsion on Q1 due to Q2. And vector F21 is the force of repulsion on Q2 due to Q1. Here F21, you can see, is a force of repulsion on Q2 due to Q1. Now, both F12 and F21 are acting along the same straight line, that is line joining Q1 and Q2. Now we come to vector form of Coulomb's law. Now to represent the force F12 and F21 in vector form, here we see F12 can be represented as F12 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by the square of the magnitude of distance, that is the distance between them, the square of the magnitude of the distance. Now into unit vector in direction of F12. Unit vector gives the direction. Since we have taken R21 in the direction of F12, you can see here R21 has the same direction as F12. The unit vector will be unit vector R21. Now also the magnitude of the vectors R21 and the magnitude of vector R12 suppose is equal to R. The magnitude is the same. So we'll take R for the magnitude. So we can write F12 equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square into unit vector R21. In a similar manner we have F21 is equal to 1 by 4 pi epsilon naught divided by Q1 into Q2 by R square into unit vector 1, 2. Here unit vector 1, 2 has the same direction as the force F21. You can see in the figure. Since unit vector R21 is equal to minus unit vector R12, here you see there is a minus sign due to the change in direction. We have F12 is equal to minus F21. Now, according to the triangular law of vector addition, we have R1 plus R12 is equal to R2. Here you can see R1 plus R12 is equal to vector R2, and from this we have R12 is equal to R2 minus R1. Also R2 plus R21 is equal to vector R1. Here you see R2 plus R21 is equal to vector R1. Now from this we can write R21 is equal to R1 minus R2. Now another way of stating Coulomb's law in vector form. We have just seen F12 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square into unit vector R21. Now that can be written as F12 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by modulus of vector R21 to the power of 2. Or we can say square of the modulus of the vector R21 into unit vector R21, or F12 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by the cube of the vector R21 into the vector R21. Now why we can write this? You can see here the unit vector R21 can be expressed as the vector r21 divided by modulus of the vector r21, and this r21 together here makes it to the power q. Now this is the formula: unit vector is equal to given vector by magnitude of given vector. Or f12 is equal to 1 by 4 pi epsilon naught into q1 into q2 upon the cube of the modulus of vector r1 minus r2 into inside bracket vector r1 minus r2. Now we can write this because we have seen just now in the previous slide that r21 is equal to r1 minus r2. So we can replace here r21. Similarly, f21 is equal to 1 by 4 pi epsilon naught into q1 by into q2 by r square into unit vector r12. Now that can be written as f21 is equal to 1 by 4 pi epsilon naught into q1 into q2 into square of the modulus of the vector r12 into unit vector r12, which can be further written as f21 is equal to 1 by 4 pi epsilon naught into q1 into q2 into cube of the vector into cube of the modulus of the vector r12 into the vector r12. We can write this because the unit vector r12 is equal to the vector r12 divided by modulus of the vector r12. Or we have f21 is equal to 1 by 4 pi epsilon naught into q1 into q2 divided by cube of the modulus of the difference of the vector r2, that minus r1, into r2 minus r1, since r12 is equal to r2 minus r1. Next, we come to principle of superposition of forces. When more than two charges, positive or negative, are present, the net force on any one charge is the vector sum of the electrostatic forces exerted by each of the other charges individually on that charge. For simplicity, let us consider a system of three charges: q1, q2, and q3. Let the electrostatic force exerted individually by q2 on q1 be F12, as you can see here, by q3 on q1 be F13. Here you can see this. You can see the direction, because the direction is showing attractive as q3 is negative, and you see q1 is positive. Then the net force F1 acting on q1 is the vector sum of the vector F12 and the vector F13. As you can see here, we have got the vector sum F12. So vector F1 is equal to vector F12 plus vector F13. In general, vector F1 is equal to vector F12 plus vector F13 plus vector F1n, where n is the number of charges present. Now we come to some previous year's ISC question paper. Question number 1. Relative permittivity of water is 81. If epsilon W and epsilon naught are permittivity of water and vacuum respectively, then the correct answer, first one, is it correct? Epsilon naught is equal to 9 epsilon W. Second, B, epsilon naught is equal to 81 epsilon W. Third, epsilon W is equal to 9 epsilon naught. And last, epsilon W is equal to 81 epsilon naught. Which of the following is correct? Let us see. We know that relative permittivity ER is equal to EW by epsilon naught. This implies that epsilon W is equal to ER into epsilon naught. Therefore, epsilon W is 81 epsilon naught. Putting the value of ER here from the question. So the correct answer is D. Question number 2. A body has a positive charge of 8 into 10 to the power minus 19 Coulomb. It has, number A, an excess of 5 electrons, number B, a deficiency of 5 electrons, number C, an excess of 8 electrons, and number D, a deficiency of 8 electrons. Since body has a positive charge, naturally it has a deficiency of electrons. Now we know that Q is equal to NE. Therefore, N is equal to Q by E. Putting the values, 8 into 10 to the power minus 19 Coulomb by 1.6 into 10 to the power minus 19 Coulomb. On dividing, we get 5. Now we see here the correct answer is B, a deficiency of 5 electrons. Now, question number 3. Explain the meaning of the statement relative permittivity of water is 81. Answer. As the relative permittivity of water, epsilon R is equal to epsilon W by epsilon naught. So, epsilon W is equal to epsilon R into epsilon naught. That is equal to 81 into epsilon naught. This means that absolute permittivity of water is 81 times the permittivity of free space. Or, from the equation, F vacuum divided by F is equal to epsilon R is equal to 81. From solving this, we get F is equal to F vacuum divided by 81. This means the force between the point charges kept in water is equal to 1 by 81 into the force between the point charges kept at same distance in vacuum. Can 8.6 into 10 to the power minus 19 Coulomb of charge be given to a conductor? Explain. Answer. As we know from quantization of charge, Q is equal to Ne, where N is equal to 1, 2, 3, 4, etc. And magnitude of charge on one electron, that is E, is equal to 1.6 into 10 to the power minus 19 Coulomb. On solving for N, we have N is equal to Q by E. Putting the values and cancelling out, we are getting a fraction 5.375. This is a fraction and not a whole number. Therefore, 8.6 into 10 to the power minus 19 Coulomb of charge cannot be given to a conductor. Question number 5. State Coulomb's law in vector form. Draw a figure as such and write the values of the forces. For example, force exerted on Q1 due to Q2 is equal to vector F12 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by cube of the modulus of vector R1 minus vector R2 into vector r1 minus r2. That is for F12, and force exerted on Q2 due to Q1 in a similar way can be written as vector F21 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 into cube of the modulus of R2 minus R1 into vector R2 minus vector R1. Now a question for my little champs. Give points of similarities and differences between Coulomb's law and Newton's law of gravitation. Now with that, goodbye and good luck. Remember, hard work is the only shortcut. We'll meet again very soon. Thank you.